without further ado, let's get into it. So the goal of this lab is just to compare the electric force from the point charge model that we did in lab 1 to a line of charges model, it was going to be computational only, because the actual experiment isn't really changing on our values. It's just the kind of model we're using to simulate it. So we're going to see what the different values are as a result of that, right? It's the same experiment, it's just we're using a different model to computationally simulate it, basically. And that model looks like us dividing the tape into multiple segments and treating each point as a point charge, rather than just treating the tape as one point charge. So that's sort of what's changing, right? And we're using glow script again, as we always do, to simulate the tape and the interacting forces. So physics principles that are applied here. It's the same as lab 1 to a significant extent. It's a Newton's second law. That's just F net equals delta P over delta T. Coulomb's law, F equals K Q1 Q2 divided by D squared. And the K is the Coulomb's constant that we all know is in the formula sheet. So that's 1 over 4 pi epsilon squared. And the gravitational force. It's just F equals mg. So that's pretty straightforward stuff, right? So just a recap of lab 1. Two pieces of U tape were given charge by quickly pulling one tape from another and thus charging it. You can see the diagram there that demonstrates as such. And the results, like the basic results qualitatively, were just that it was determined to have a positive charge. We tested it against a pen with a negative charge, and to determine that they did in fact attract. We then taped a piece between two blocks and we placed another below it to see the reaction, and the tapes revolved and floated. So the tape that was on the blocks went upwards and sort of floated there until the forces sort of cancelled out, right? And the distance was measured at 0.016 meters. And here you can see like sort of a summary of the results for lab 1. Yeah, that's pretty straightforward. Let's move on to the new computational model that we're using in this lab, right? So each piece of tape is essentially multiple charges in a line. I've already talked about this, right? Some of the assumptions that we're doing here is that air resistance is negligible. Each piece of tape has the same charge. So yeah, and the charge is equally distributed along the length for our new model. So getting into the code here, it's nothing too insane here. So you can see what I'm doing here. It's very similar to part 1, but sort of changing stuff here to accommodate the new model that we have. You can see here that I'm simulating the charges on both the top tapes and the bottom tapes, and I'm calculating the electric force that's acting on the top tape due to the bottom tape. And that is being done using the line charges model, right? And this NA stuff is just sort of like the representation of that you're going to see in the diagram that the code generates, basically. But this is like fairly simple, straightforward stuff. We're just simulating and calculating the force that's being carried out, right? And you can see here like our constants and stuff. And so this is the result that we ultimately get, right? The magnitude of the charge is at a line of charge 3.695 e to the minus 8, and the magnitude of the charge on the tapes as a point charge is 1.980918 e to the power minus 8. So these are the two different values that we get from the two different methods of evaluation. So the one at the top, that's lab 2, sorry, and the one at the bottom, the second one, that's lab 1. So you can see the difference in the values there. So there's a few sources of error that might mess up our experiment, right? So charges may be unequal on each piece of tape due to changing values. We may have some human error in taking measurements. So for example, a limited degree of accuracy for example, if I'm measuring a tape. And the forces from the surroundings, for example, wind, etc. Like once again, we assume no air resistance, for example. That might not necessarily be true. There might have been a light breeze in the lab, for example, stuff like that. These are all sources of error for like the actual experiment that we did that caused this problem, but also for the data that we put into our computational model, right? So for example, taking measurements or the charges being unequal, this sort of factors into our computational model being inaccurate to real life as well. Lastly, the what if and why questions, right? What if we modeled each tape as a single point charge as done in the previous lab? So the difference I've already sort of shown in the results screen that we had, but there's two significantly different values, right? So clearly those models produce different results. And why do these estimates differ necessarily? That's because the point charge model simplifies the experiment, and it's a completely different model to the line charge model. And so in reality, it's a lot more truer to the line charge model. There's still some inaccuracies. So for example, we assume the charge is equally sort of spread out. That might not necessarily be the case, but ultimately